In this video, we're going to demonstrate how to use Microsoft Excel to carry out a post hoc analysis following a one-factor repeated measures ANOVA in the event that the ANOVA revealed that there was a statistically significant difference across the levels of our independent variable. So we see we have our fictional data here where we have 10 research participants that were evaluated 5 different times sequentially at 3-minute intervals with respect to the degree of unsteadiness while riding a bike. And to begin here, what I'm going to do is I'm going to use the data analysis tool to carry out the one-way ANOVA. So I'm going to click Data, I'm going to click Data Analysis. Two-factor without replication is the one I want. I'm going to click my labels, and in the input range bar I'm going to highlight all of the data I want to work into my analysis. Now what I'm going to do here is I'm going to click output range, and I'm going to indicate to Excel to put the results of the ANOVA onto the same worksheet. Typically this would open up into a different worksheet, but I want it right here because when doing the post hoc analysis I need quick reference to those values. So once I have that set into the output range, I'm ready to conduct the ANOVA, and we have all of our data from the output. What we're going to need with the post hoc test is we're going to need the labels here for the levels of our independent variable, and I'm just going to go ahead and highlight those. And I'm going to highlight the average values that were obtained or calculated at each of those levels. So I'm just going to bold that, and I'm going to make that red. Now when we scroll down to our ANOVA table, what we'll see here is that we have a p-value for our time variable that is very, very small. So that indicates that we do have a statistically significant finding. For the post hoc test, I will need the degrees of freedom that is related to the error term, as well as the mean square for the error term, and I'm just going to bold and make that red font just to note which data I'm going to need. So what we see here is the Fisher LSD, or least significant difference equation, that we'll use for the post hoc testing. Unfortunately, Microsoft Excel does not have an automated feature to do the post hoc testing, so I'm going to do this manually here in Microsoft Excel. So the first step is to calculate the critical t-value that we're going to need to put into this equation. And I'm just going to give that a label here, critical t-value, and I'm going to ask Excel to look that up. So I'm going to hit the equal sign, I'm going to hit t.inv for the inverse of the t-distribution, and I want the two-tailed value. I shift 9 in the parentheses, and the probability I'm going to select 0.05 since that's been the alpha level that we've been working with so far. Then I hit the comma, and here is where I enter the degrees of freedom for the error term. I could click this cell and that would transfer that value, but since I'm already here, I'm just going to type the number 36. I'm going to shift 0 to end the parentheses. To close it, I hit enter. Now we have our critical t-value that we can use into this equation. The next step here is to actually calculate the Fisher least significant difference value. So what this value will be used for in the next video is to compare the differences across the levels of our independent variable here. Our independent variable here being time, and so because the overall ANOVA showed that there is a difference somewhere in here, we need to explore where those differences exist. So I'm going to type into this lower cell right here, I'm going to give it a label, Fisher least significant difference at the indicated alpha level, and I'm going to go ahead and start my calculations. So I'm going to hit the equal sign, and I'm just going to click this cell to bring in that t value. Then I'm going to shift 8. I'm going to multiply that by the SQRT, or the square root of everything inside that square root symbol in our equation. So I shift 9, and the first value is I need the mean square, or the variance of the error term. So I'm just going to click the cell, and that'll automatically input it. And I need to multiply that value, asterisk, then I'm going to shift 9 again, and I want to calculate 2 divided by NG. That is the number of participants in our group, and since we only have one group here, that's our sample size. So I'm going to type in the number 10. I'm going to close that parenthesis, and then I'm going to close the next one here. So we have 2 sets of parentheses that we want to carry out. Now I hit enter, and we have a Fisher LSD value of 8.28. This is considered to be the statistically significant difference between the time points of interest. And what the next step to do is to actually calculate differences between these averages, and in the next video we're going to set up a matrix of the headings and the averages. We'll calculate the differences, and then we'll use that value to compare against our significant difference value.